This video is sponsored by PCBWay.
Hey there, this is Seth Schaefer from Team Just Cause Robotics, and in today's video, we're going to be talking about puncher shrapnel mine for realsies this time. This is going to be a design overview video where I talk about the technical details of the robot, how I came to the decisions for the different components that are in here, and exactly what worked well and what didn't, because this is the first time I'm ever doing design review video, both after the robots actually competed for the first time, which means that you get to learn from my mistakes as to what didn't work so well. Whereas in all my other design videos, I usually am talking about what I hope will work and think will work. Now I actually know what worked. If you want to actually see all the fights from the competition, well, I'll have a video out with a full event recap in a few weeks, but if you want early access, you can subscribe to my Patreon link down below, and at any paying tier, you'll be able to watch all of my fights from the RCE event, which unfortunately was not live streamed, so that's the only place you'll be able to see them for right now. So I'm going to try and break this down into different sections, though as I record, I tend to ramble since I don't have a script for any of this stuff. I just have a general outline here. So the key aspects I want to go over are like, basically, why did I even make the robot a puncher in the first place, and what are the advantages of the puncher system? And then how did I approach the design of the puncher mechanism? Why did I choose the different components I chose for the weapon system, the drive system, and the slider mechanism? What are the electronics like, what components I used, and the good and bads about those things. And then we'll look a bit more at like the mechanical design of the robot and like why I chose what materials I did for which parts, whether those worked well or didn't, what I might change in the future. And any other final thoughts I have about whether this worked well as a whole and what I'm going to keep or change moving forward. Alrighty, so first off, why did I bother making this complicated and annoying punching system in the first place? What advantages does this have? Well, like I mentioned in my last video, the main advantage to the puncher is basically that I can get more bite than I could without it, and also, more importantly, I can pin an opponent in place and hit them a bunch of times with the spinner moving each time, rather than having to drive away and let them run free and then come back in for another hit like a traditional vertical spinner would. The other advantage to the puncher system is that I don't need to dedicate quite as much weight to beefing up the spinner and its mount, because I can retract it out of the way so that it doesn't get directly hit by, say, a horizontal spinner, which is by far the worst thing that can happen to the puncher system. It's just not mechanically designed to take forces like that. But I can have a relatively lightweight blade and spin it really, really fast and then punch into my opponents to deliver extra bite, rather than having a really heavy and beefy weapon system that needs to take the full force of my opponent's hits and then also need to drive really fast into them to be able to deliver a hit. The other idea behind this was, my original goal with the first version of Shrapnel Mine was to be able to pin people and saw through their bottom plates, and I'm not necessarily going to always access the bottom plate of my opponent, but by being able to pin somebody and then send the weapon into them, it's more likely I can get them up at an angle where I can send it into their bottom or some other vulnerable part on their robot. So that's the main idea behind the puncher, and no, it's not just because it worked well for Tantrum and I wanted to copy Tantrum. Honestly, I think that the puncher system on Tantrum is kind of anemic. Like, the weapon was not really hitting all that hard in almost any of their fights. Tantrum won its fights because it had an insanely good drivetrain and a shitload of magnets holding it to the floor so no one could push it around. I don't have the benefit of running magnets on this robot because it's going to be running on wooden floors. So I had to approach the design completely differently from how Tantrum was designed. Also because it's a 3-pound robot instead of 250 pounds. Now, the next thing I want to talk about is just my general design philosophy for this robot. So, like I said in my last video, keep it simple, stupid is the best design philosophy for combat robots. Anything that is unnecessarily complex should be removed from your design because it's much more likely to break in combat. Now, with this, I tried to do everything pretty much as dead simple as I could. You've got the slider driven by a belt drive with just one actuator directly coupled to a pulley, directly coupling the belt to the slider. I'll get into that more in a bit. The drive is all direct driven on the back wheels and then belted to the front wheels. It's exactly the same as what I do in SSP kits. And in fact, I'm actually using the same wheels as the SSP kits. I just am using longer belts. And then the electronics are super densely compacted into just this back section here, which I'll talk about again in a little bit when I get to the electronics section. But overall, this is kind of a proof of concept for whether this platform would work well, and also a way to test out my brand new Blitz Pro Drive motors, which I'll also talk about more when I get to the drivetrain section, because I'm actually using the Blitz Pro Drive motors not just for the slider, but also for both drive sides. So even though this one is the only black one, it's just because these were the prototype ones. So yeah, overall, this was kind of a proof of concept for whether I could get a puncher robot within the weight limit and have it be durable enough to survive fights, and whether I could get the system to actually do what I was hoping to accomplish with the first version of Shrapnel Mine, which is to actually do some damage. And I think I actually was able to accomplish all three of those goals, and there's definitely lots of improvements that could be made to make this better. But I'm pretty happy with how this bot sits as it is, and I was never really happy with Shrapnel Mine version 1 or the slight redesign that I made in 2022 for it. This I'm much happier with because it drives super well. It's got a really nice, powerful, pushy drive system, and I don't have to worry about it being too fragile to take a hit. As you can probably tell, it's taken quite a few. All right, I know looking at CAD designs is super boring, so I'm going to try and minimize that in this video, but I want to first start with the puncher system. So this was the first part of the robot that I designed. Normally, when I am advising other people on how to design a combat robot, I tell them, make a robust drivetrain first, and then use the rest of the weight you have for your weapon system, because it's easier to cut weight out of your weapon blade than anything else, and if you can't move, you lose. In this case, I went the other way around because A, the packaging requirements of the robot were going to be 100% based on the size and shape of what this weapon system would take up. And B, I already designed a robust drivetrain. Like I said, I used almost the exact same thing I used in the SSP kit, except replacing the Dartbox drive motors with my Blitz Pro drive motors. So here is the slider system. This is the carrier mount plate. So let's isolate that for now. And essentially what we've got is a CNC machined 7075 aluminum billet part. That is this part right here. This was machined by our sponsor PCBWay. PCBWay has been a sponsor for this channel for a long time. They make CNC machined parts for me all the time, often out of aluminum, but some other materials too. They just recently made some parts for Bloodsport out of grade 5 titanium, but this is 7075 aluminum, and it was pretty much cheaper to get 3 of these made by PCBWay in China and then shipped here to the US than it would have been for me to machine them myself, because even just buying the material to do it and the tooling would have cost more than the finished parts from China plus shipping. So highly recommend them. Check them out, linked in the description for $5 off your first order. So that part I tried 3D printing in nylon at first and it just broke. I'll probably show a video. I think I showed that in the end of my last video. And that's why I decided to go with the CNC machined aluminum for this. So it's pretty simple, all things considered. It just has to have 4 screw holes to hold it to the carriage, 2 screw holes to bolt the belt on so that it slides along the rail, and then 4 screw holes to hold the hub motor to it. The interesting aspect of this is that it's not supporting the hub motor on both sides. I did not design the RDY 5022 Mini to be supported only on one side. To be honest with you, this is not how I recommend doing it. However, I did it anyway, basically to see if I could. It turns out I could. I wouldn't necessarily recommend anyone do this with the current version of the RDY 5022. But the next version that I get in is going to be redesigned slightly to make it so that the outer bearing here is better supported if you were to mount it only on one side like this. And I think for probably most 1-pound robots, it would be fine to do something like this with the new version. For a 3-pound bot, like I said, I can kind of retract this out of the way and I don't have to worry about things hitting it. I really just have to worry about the force of the weapon's own hits, which are going to be trying to torque this over like that and break the motor off. So I just needed that central shaft to be strong enough to support those loads, and it is. And then I needed this billet part to be strong enough to prevent it from wrenching apart this linear guide, which it also is. Slider motion is provided by a Blitz Pro 5.2-to-1 drive motor, exactly the same that I'm using for the drive system. And then I have a aluminum off-the-shelf 10-tooth XL pulley and an XL belt. and then a 3D printed nylon XL pulley that I just drilled out so that it's a slightly loose fit on a 5mm dowel pin. And the dowel pin just presses into this part. There's nothing retaining it at all except for friction, and that just worked fine because there's no reason there would be any force axially on it anyway. Alrighty, so now we're looking at the render view of the CAD for the robot itself. And I'm just going to pop back into the design view. So again, I don't want to show you the CAD for too long because it's boring, but I just want to point out a couple things. Number one, if you look at the robot from a side profile in real life, it does not look like this because it turns out that this 4-in-1 ESC is bigger than I thought it would be. I designed this CAD model without one for reference, and it turns out the power wires stick out past this point. So the robot can't drive upside down, which was a mistake I only found out when it was basically put together, and then I didn't have time to change it before it had to fight. All the electronics for the robot are right here, which is great because there's like almost no wiring that needed to be done, but terrible because the little wiring I needed to do was a huge pain in the butt. So what this is a DYS 65 amp 4-in-1 ESC, and it was kind of a pain in the butt to use. The ESC kind of sticks out over here, but I had originally designed it so that you can see if you extend this line forward, it kind of makes it so that when the hub motor is slid all the way back, even if the blade's not spinning, the back wheels should have traction. It should be able to drive upside down. And when it's right side up, obviously there's plenty of ground clearance underneath the robot. And the only other thing I wanted to show in the CAD view that I can't show in real life as easily is I use slightly different ones in real life, but the way that I attached everything to the base plate, 100% of everything except for the linear rail is attached by using plastite screws, number 6 plastite screws. And then for the linear rail, I used what are called PEM nuts, or press insert nuts, or self-cinching nuts. But essentially you can buy these off the shelf from like McMaster or whatever, and they're called press fit nuts or whatever. You can get ones that are specifically for soft metal and plastic, or ones that are specifically for composites like carbon fiber. And they're designed to be pressed into a flat sheet and then provide metal threads in that sheet, which either would otherwise be too thin to support threading it directly, or just a material that's too soft, like the carbon fiber in this case. So by using these press insert nuts, I was able to get pretty strong M3 threads in a carbon fiber plate that's too thin to thread the screws directly into it, and the threads would probably just crumble because the composite isn't really designed for that. There's also these two holes here, which are for the weapon lock. Looks like this. This was just a 3D printed PLA part that I was able to shove into those two holes, and it was like a relatively tight fit, so it didn't just fall out on its own. Now let's go to the physical robot and I can show the rest of what I'd like to talk about. All right, I want to try things a little bit differently from how I've done past design videos and show you the physical robot a lot more. So I actually set up my Insta360 as a webcam. So now we can get this nice webcam view of the robot itself on this table. I've already recorded this once, so I might cut back and forth between me doing it live here and the previous segments I recorded if I flub any details here, but I'm going to try and do this pretty much all in one take. Puncher system, I used this CNC machined 7075 aluminum bracket to attach this to the slider carriage. This slider carriage and rail assembly are something you could just buy on Amazon. Pretty much everything on this robot is an off-the-shelf part, or one that I sell, or just laser cut steel, except for this one piece. I CNC machined myself this carbon fiber base plate, but you could get this from like Singasend or CNC Madness for a lot cheaper. I CNC'd this myself because I was running out of time, but it's 3mm thick carbon fiber, and it's like insanely, like absolutely ridiculous how rigid this plate is. Since pretty much 100% of the loads the robot will experience in fights is going to be transitioned through the base plate, I wanted it to be really beefy, and it's really beefy. So you can see I basically have a bunch of 3D printed nylon and TPU, and that's about it. The lid was also 3D printed nylon. That was simply because I ran out of time to get carbon fiber that was thin enough that I could machine myself for it. And yeah, that was just me procrastinating basically. To get the decals on the lid, I tried two different methods. The first method came out like this, and this is, I just painted it black. This was white nylon. I painted it black, and then I laser engraved the text. It looks kind of crappy because the laser also melted the nylon. Then for this one, I painted it all black, and then I put masking tape down, and I just lasered the profile of the letters, which only took like 3 minutes. And then I just picked out the letters with tweezers and painted white and the stripes as well. And this came out, I think personally, much better looking. And it took way less time because it took like an hour and a half just to engrave away the paint on that first lid. Even though it took me like 15 minutes to pick away all the tape spots from the letters, I think this was a much better method, and I'll probably do that more in the future. If you don't have a laser cutter, and you do have a Bamboo Lab printer like I have, you could probably just do a 2-color print. I just didn't have black nylon on hand. I only had white. So I couldn't just do a 2-color print. And also any 3D printer, you could probably just print the letters and then swap filaments manually and print the rest of the part in black and get the same effect. All right, so with the broken, messed up lid off, turns out nylon's really easy to shatter and crack and is bad. And I won't likely use it for pretty much anything except for this pulley in the next version. But it held up just barely well enough. But a lot of parts are cracked. So like this slider motor mount where these holes are cracked, it also cracked on the mounting holes underneath. I had to drill out a lot of holes to larger than I thought I would need to for the plastites to go into them without cracking. So definitely going to be switching that filament for next time, but all the white parts are printed in Cheaty, EZPA, nylon, or whatever they call it. Anyway, it's not that durable. I didn't boil any of the parts to anneal them, but I don't trust that it would hold up even if I had. So the way the battery is held in is with this white piece that screws in from the bottom, which is kind of a pain, but I don't know of a better way to do that because I need to make sure that the blade doesn't hit the battery and it doesn't just flop in here. So that can come out. And then I have this switch PD board for basically no reason. It really could just be a PCB switch. And the power electronics are all just a 4-in-1 ESC with a receiver soldered to it, which I'll show in a minute. And so that's just one plug, and then this is just a switch in here. Everything that you see that's red or blue is 3D printed TPU, and that's just your standard bog standard 95A TPU. And I've got a separate piece here, separate back piece here so I can show the detail a little bit better. So the drive motors cannot fit in here without bending it out of the way. But once you do flex it out of the way, you can get the drive motors in and out pretty easily like you just saw. And then they're secured with a square imprint so the motor can't turn, and then some M3 screws to prevent the motor from being able to pull out this way, even though like the motor can would hit this, but it's spinning and I don't want it to hit that while it's spinning. And the wheels are just set screwed on like you would with the SSP kit. They have aluminum hex hubs inside that fit on the 6mm shafts. My standard fork config is actually TPU 3D printed forks with just some screws holding them on. And this actually worked great because it couldn't get caught in floor seams since they're not super sharp, but obviously you're not going to get under people. And more importantly, this claw geometry is much better for fighting beater bars because when they hit here, they get like blasted back sometimes. The claw thing has worked really nicely on SSP, and I wanted to keep it for this type of design because it works great as a control counter to beater bars. The Blitz Pro Drive motors themselves. Let's talk a bit about these. So this is my newest product. And I designed these basically because the same system worked well for Shrapnel Mine version 1 and Division version 3. So these are the Blitz Pros. This is the Blitz motor, which is a 2306 650 kV, very low kV brushless motor, coupled to a 5.2:1 ratio 24mm diameter gearbox. As opposed to my 22mm diameter gearboxes, these have mod 0.4 gears. The 22mm have a mod 0.3 gear, which doesn't sound like a big difference, but it's a pretty big difference. The gears in these are much bigger and much more durable. The output shaft is 4140 hardened steel billet shaft design, so that it can't come out of the carrier plate because the carrier and the shaft are one piece. And then the front has square cutouts for weight reduction and for making it so that you can put it in a 3D printed mount and it won't turn. And also M3 tapped front plate mounting holes. So you can secure it to your robot frame without using tiny little M2 fasteners that'll bend or break easily. So this as a whole package you can buy for $52.50 each, or you can buy a set of 2 motors and 2 matched speed controllers for $150. So that's basically $5 off. This form factor is shorter than anything else on the market with a 24mm gearbox because I cut out an entire gear stage, and that means that the whole gearbox is 5mm shorter. And so even with this absolutely gigantic motor, you're still able to fit this into pretty tight spaces. In fact, it's even shorter than my 22mm brush drive motors. So the reason I made this and then put it in Shrapnel Mine, you might be thinking, oh, you designed this new product and you're just putting it in Shrapnel Mine so that you can sell it to people. And that's not really true. Actually, it's sort of the opposite of that. I designed the original Shrapnel Mine with a 2306 motor and about a 5-to-1 reduction. And it was super powerful, plenty of torque to push other robots around. The only problem is these motors were only available in 1700 kV. And for a long time, I've also gotten some custom motors made which are 1000 kV, which is a lot more controllable and still pretty powerful, but still has a top speed of like 25 miles an hour, which is completely useless in an 8-foot arena. So basically, this is the same thing as this. It's just way easier to just plop in a robot, and it's way smaller. The only downside is, of course, this is a longer setup. So even if you imagine the wheel is directly attached to the shaft, the motor sticks out past where the motor sticks out in this case. But this is a much more robust solution. I had problems with the wheels getting knocked off of Shrapnel Mine when it was fighting Caldera. And the shaft is really well supported and it shouldn't just break off, especially if you just surround this whole motor with TPU like a lot of bot builders would do. With the Blitz Pro Drive motors, I also sell matching single ESCs, but for this robot, because of the packaging constraints, trying to get everything as tight as possible, I decided to go with a 4-in-1 ESC, as you could see. So let's go back to that webcam view. So the 4-in-1 ESC is right here. I think I can finagle this out so you can get a better view of how all the wiring and electronics are set up. Give me a second here. First, we got like that, and that. Normally I take the side armor off before doing this. But yeah, and then I can just unplug you, and the rest of the robot can go somewhere else. And you can see where that other rear armor piece would go. So yeah, this is 100% of the electronics in the robot other than the switch and the battery. I have an FS2A receiver directly soldered to a custom BEC I designed a while ago. This could be any micro BEC, but I already had these on hand because I designed them. And I haven't started selling these for various reasons, but I'll probably make a standalone BEC product at some point that is slightly different than this one. So those are soldered together, and then there is an 8-pin connector on the ESC, which has the signal channels broken out and then battery and ground. And so that's all just direct wired to the FS2A. I won't go over this closely because it was a huge pain. The upside to a 4-in-1 ESC is that, as you can see, this is all the wiring for the whole robot. That's pretty nice. But the downside is that programming this is a huge pain since you can't have the receiver connected to it while it's being programmed, and all 4 channels act like a single separate speed controller. So I had to break out the signal wires one by one to a programmer and then solder them onto the FS2A, and now it's a huge pain if I ever want to change the configuration without wiring up another custom 8-pin connector thing. But like I said before, the 4-in-1 actually sticks out further than I thought because the power wires are like attached to this little sticky outy part, which I didn't know existed when I bought the ESC since there's no CAD model posted for it. So what I think I'm going to do is switch to this one in the future. This is a Neutron 45 amp ESC instead of the 65 amp, but both of these have AM32 firmware, which I really like, and 45 amps is probably plenty for this bot. Even if I up to 6S voltage, the motors draw like 10 amp. The drive motors, the Blitz Pros, they draw like a max of like 10.3 amps even on 6S, and the weapon motor will probably be a little spicier than that because it's a 1700 kV, but I can step down to the 1100 kV, and I think that'll run just fine and give me a pretty similar tip speed to what I was getting before. The major benefit to going to 6S isn't about getting more drive speed and power, but about getting more slider speed and power, because I think the slider is a little slower than I would like. Basically, when I did my math designing this, I did it wrong, and I thought it was going like 10 times faster than it actually is. But it's right now punching at about 4 miles an hour. I confirmed with like a high-speed video that I'm getting about that. And if I run 6S, that'll go up by 50%. But a bigger improvement I can get is simply by making this pulley that drives the belt from the motor bigger. Because with this, I could get double the speed if I went to a 20-tooth pulley, for instance. So I'm probably going to experiment with different pulleys on back here, in addition to maybe upping the voltage. But having this much smaller 4-in-1 ESC will make it so the robot can actually drive upside down like I want it to, instead of this hitting the floor and lifting the wheels off the ground, as you can see there. That should certainly help. So this ESC and the other ESC, they both have a 30.5 millimeter hole spacing here and here, but then this one, you can break those tabs off, and then it's only a 20 millimeter by 20 millimeter hole spacing on the center portion, so the overall footprint is quite a bit smaller. Other stuff that I'd like to change is I need some sort of a bumper stop on the ends of the slider so that it doesn't put as much strain on the motor. I didn't have them fail at all in combat, but in testing I did have the pinion on the motor slip, and that's going to be probably partially addressed by a design change to these motors themselves in my next batch, where I'm going to be knurling the shaft in addition to the pinions being pressed on. But I still would like some extra insurance, so just having like a TPU 3D printed bumper so that it's not slamming full stop on either end, especially if it's moving like twice as fast, I think will be probably necessary in the future. Otherwise though, the slider system was very robust and I didn't have any problems with it in combat, other than forgetting to Loctite a couple of nuts and having them fall off of the securing this to the belt. So it decoupled from that, but once I put those nuts on with Loctite, it was fine for all my other fights. So what improvements am I looking to make in the future? Let's just talk about that for a second. So like I said, different 4-in-1 ESC, maybe a 6-cell battery are the two major electrical changes I'd be looking at. As far as mechanical design, the 3mm base plate's fantastic. I'm keeping that. I definitely want 2mm carbon fiber on top instead of nylon, but again, I intended that from the start. I just didn't have time to make it. Maybe even 1.5mm on top because it doesn't need to be structural necessarily. One other issue I had was, this is what the lid looks like when it's in one piece. When I was testing, I found that I didn't make this this cutout far back enough. So the motor, while it doesn't seem like it should be able to hit, it actually was like taking a chunk out of the lid. Whoops, you can't see that. This was like able to hit the lid somehow, even though it doesn't seem like it should be able to. And in the CAD model, it's like able to miss by a tiny little bit. But yeah, so I think what happened was just this is going back a tiny bit further than it should and hitting there. So I'll have to change that profile on the lid a little bit. Not a huge deal. All of the parts that are currently 3D printed nylon, I'm going to probably change to a carbon fiber TPU or something else that's more impact resistant, because the nylon just did not work well. But I need some rigidity in the slider parts in order for the slider to work. So they can't just be regular TPU, I don't think. Hub motor setup, I have to figure out whether I want to change up the carriage design so that I support the hub motor on both sides or not. If I do that, the reason it's not like in the center of the rail is because I'd have to raise the motor up a lot higher to be over top of the rail and the guide. So I might just like extend it forward and then have like a fork that comes out, but you can see like the blade comes back behind the slider carriage and in front of the slider carriage, right? So if I want to support this on both sides, I need to somehow, go outside that blade diameter to support it, and that makes the whole setup a lot bigger. So I think instead I'll probably just stick with the redesigned version of the 5022 hub motor, which will be better for single side supporting. And I also might try and make the blade a little bit heavier and store a bit more kinetic energy for the next version as well, since this one was just like a super simple afterthought of a design that I wanted to get cut, so I had something. But yeah, overall, I'm pretty happy with how the bot worked, and I'm really excited to bring it to more events in the future. Make sure to subscribe so you don't miss it when I post my full event recap in a week or two, and hit the bell icon so you get notified when it comes out as well. Like if you like this video, and comment if you have any questions down below I didn't answer. All right, that's all I've got for you today. Bye-bye.